Here are some of the signal generators that you'll see in use in schools. Despite the wide variety of signal generators, they all have certain controls in common. Look for the range control, the waveform or function control, or switch, the frequency control, or the amplitude control. In addition, some signal generators have an attenuator, and for our purposes here, we will just set that to 0. Signal generators are often connected to loudspeakers so that classes can investigate different sounds. Often they're connected to an oscilloscope so that pupils can see the shape of the signal and how it varies with time. This particular signal generator can also function as an amplifier. If you're using it as a signal generator, make sure that this little switch here is in this position. My signal generator here has 3 sockets instead of the 2 sockets you might expect with a power supply. Wherever I connect to it, I'm always going to connect a wire into the green socket, and if I'm connecting a loudspeaker, I'm going to connect into this other socket marked low. Now the connecting lead for my oscilloscope doesn't have green and yellow sockets on it, it has black and red sockets. What I've done, and this usually works, is I've connected the black lead to the green socket and the red lead to the yellow socket. And not every signal generator uses these colours. Here's my loudspeaker connected as well as the oscilloscope, and what we're going to do is look at the controls I mentioned one by one and see the effect that they have on the output of the signal generator. First off, we're going to look at the frequency control. Now watch the oscilloscope screen as I turn up the frequency. The frequency is the number of oscillations, that's electrical to and fro's every second, and if I increase the frequency, I increase the number of these that you see on the screen. Listen to the effect that altering the frequency has on the pitch of the sound. High frequency means high pitch. Frequency is measured in hertz. A frequency of 50 hertz means 50 oscillations every second. If we look at the numbers on the frequency selector here, we'll see they go up 1, 2, 3 all the way around to 11. Now that 2 there doesn't necessarily mean 2 hertz. To see what it does mean, we have to look at the range selector. This is my range selector here, and you'll see it's set to times 100 hertz. So that means the 2 that we saw in the last selector really meant not 2 hertz, but 200 hertz. Now your signal generator will have one of these range selectors on it, and the times 100 setting is probably the best one to have it on, at least when you're setting equipment up. Another control you'll use is the amplitude control, sometimes just marked output or output level. Watch the oscilloscope screen when I turn this one clockwise. And now listen to see the effect that that has on the sound. This time we're not changing the pitch or frequency of the sound, we're changing how loud it is. Referring to the electrical signal, we're changing the voltage of the electrical signal. We'll now look at the effects of altering the function or waveform control. The waveform you see just now is called a sine wave, and that's the one you'll set your signal generator on if you're going to drive a loudspeaker. This is called a square wave. It's an example of a digital signal where it's only got 2 values, a high value and a low value. That's called a sawtooth, and to be honest, you're unlikely to need to set up a signal generator to give a sawtooth output for most school applications.